This is video 471, and the goal of this video is to look at inverse functions. So inverse functions are key because they help us find missing values for trigonometric functions. So if I'm looking for the angle, I can find it. But first, let's talk about the graphs of the trigonometric functions and how they help define the actual inverse functions. So the sine graph, we know the sine wave is this nice curvy wave. Notice that dotted line. That dotted line is trying to show you that this function does not pass the horizontal line test. Meaning, if I find the inverse function, in this case the inverse function is simply a flip over the y equals x. So the x and the y's switch. So of course now we'd have a vertical wave like this if the x's and y's switch, because now my y's are my angles and my x's are my sine values. Okay, notice the function here. But the issue is this is not a function because, remember, a function cannot have 2 points that have the same outputs, and those 2 points do as do many others on that vertical line there. So we have something that's not a function. So what we have to do is chop off sine and only take a snapshot that is a function. So here's one idea. We could snapshot this little bump right here. But notice it would not pass the vertical line test still, because it would have, these 2 points would have the same output. So we have to figure out what section will give me all of the possible outputs from 1 to -1 without having duplicates. And the answer is to snapshot from pi over 2 to -pi over 2. That snapshot is from here to here. It gets all my outputs of 1 to -1 without duplicating any of them. That is the restricted sine function that we will use to define the inverse functions. Okay? So the inverse functions will only, if you use your calculator and you ask it and you use the inverse of sine, it will only ever give you answers between -pi over 2 and pi over 2. Now if it's in degree mode, of course that means -90 to 90. It will never give you an output of, for instance, 270 degrees or 3 pi over 2. If we asked it what sine has, what angle has a sine of -1, it will always tell us -pi over 2. It will never give us the answer of 3 pi over 2. So, with that said, we have to define the sine inverse function so that everyone knows what we're talking about. And this is the definition that is used for all math classes. So the first thing, the domain. The domain, remember, is the possible x values. Now this sine function is asking, when it says y equals sine inverse of x, it's simply asking what angle, y is your angle, has a sine with the value of x. So this is the sine of the angle. And it's asking what angle has that sine. That's what sine inverse is asking. So for x, the domain for x is going to be from -1 to 1. Because we can never have a sign that's bigger or smaller than -1 or 1. Okay, so that defines my x values, -1 to 1. Just like the sine wave, not the inverse, has a range of -1 to 1. Sine inverse has a domain of -1 to 1. Now, what is the range? The range is, like we talked about, -pi over 2 to pi over 2. This is going to be key, because sometimes you're going to look at your unit circle and you're going to find answers that are not in that range. And you want to be careful, backtrack, and think about what angle is in that range that satisfies the equation. So, of course, that means now mine going to be from pi over 2 down to -pi over 2. And then my wave, using some basic key points, I know that -pi over 2 gives me a sine of -1. 0 degrees has a sine of 0. And pi over 2 is a sine of 1. And what happens is, remember, this is a sideways wave. So if I were to keep going, I would have the sine wave. So that's the graph of sine inverse. Now we are not going to be graphing sine inverse, but we need to know things like the domain and range in order to calculate sine inverse functions. Okay? So in order to calculate things. So we won't actually worry about the graphs or the transformations of the graphs and so on. We're mostly worried about the domain and range of these functions. Now let's take a look at cosine. The same thing works for cosine. We have this function where the cosine is this function that repeats itself. And when we turn it on its side for the inverse function, we have a function that is not good enough because it is not a function. It has multiple values that overlap, making it not a function. So again, we got to think about where to chop it off. And in this case, we chop it off from 0 to pi. Okay, so it's different than sine because, of course, the wave is different. Again, this little section will account for all values from 1 to negative 1. So we chop it off there, and whenever we ask for an angle, we'll give an answer of 0 to pi, somewhere in that range. So that's what the graph will look like. The inverse function, once I turn it on, when I reflect it over the x equals y line, that's what it will look like. Okay, and it will be a function from 0 to pi is your domain. So is your range. So our domain is the x values, and the x values that's going to be from negative 1 to 1. Because remember, those are the possible cosines of some angle. And then range is going to be from 0 to pi. That's very important because, again, your unit circle has multiple values where the cosine is from negative 1 to 1, but you only want to give the answers that are between 0 and pi because then they don't repeat yourself. So now my graph is going to look a little bit different. It's still going to go from negative 1 to 1 on the x-axis, but now it's going to go from 0 to pi. And what we need to remember about cosine is that it hits 0 at pi over 2. So my graph, and then at pi, it's negative 1. At 1, it's 0. 0 degrees gives me an angle, cosine of 1. And then here it's pi. So it's this wave like that. So there's your wave, your graph. But again, what's most important is that we understand what the domain and range are for these functions. So that's the things you should have written down. So here's how we'll use that to actually calculate things. So the most important thing to remember is understanding what this means. Sine inverse of x is asking for an angle, excuse my words here, I'm messing up, for an angle that has a sine equal to x. Okay, it's asking for an angle that has a sine equal to x. So this is saying what angle, so sine of some angle theta is 0. It's asking for where the sine is 0. Now again, we want to keep in the range, so from negative pi over 2 to pi over 2, where is the sine 0? That should only occur one time in that range. And the answer for theta is that it equals 0 degrees, or 0 radians. At 0, the sine is 0. So again, cosine inverse of x is asking the exact same thing for an angle that has a cosine equal to x. Okay? And in this case, we want a cosine equal to negative 1. So from 0 to, and we're looking for the angle from 0 to pi because now it's cosine. From 0 to pi, where is the angle equal to negative 1? The cosine of the angle equal to negative 1. Now again, I can look back at my graph, or I can think about on my unit circle. Cosine is negative 1 at pi. So the answer here is pi. Tangent inverse of x is asking the exact same thing, so I'm not going to repeat that, but it's the exact same thing. It's asking for an angle that has a tangent equal to x. So in this case, where is the tangent negative 1? Now tangent, we did not talk about the range, but the range for tangent, because remember the asymptotes kind of define your period, and notice it never repeats itself. It has all values from negative infinity to infinity. So the tangent actually will have the same range as sine. It'll be from negative pi over 2 to pi over 2. That's the possible values we're looking for. So we look at our unit circle, we find out where is the tangent negative 1, and we see that it's at pi over 4. We're looking for the angle that has a tangent of negative pi over 4 in that range, and this is the range for tangent. So let's show you some problems that you're going to be solving for today. So the best steps to evaluate inverse functions. So number 1, rewrite the sine inverse of x equal to theta as sine of theta equals x. Most of you will make sense of that a lot better than cosine inverse of something. So I'm always going to rewrite it. So let's see that with the example. We're going to rewrite this as cosine of some angle equals square root of 2 over 2. Now, I'm going to do step 2. Find the values in the proper range for theta that satisfy the equation. So now I look, and I know the range for cosine is from 0 to pi. Okay, I have to memorize that. Now I'm going to be looking for where is the cosine square root of 2 over 2. So I'm looking at my unit circle. I'm finding the point, the x value that's square root of 2 over 2. And the x value that's square root of 2 over 2 is at when theta is pi over 4. So there's my answer, pi over 4. And again, there are infinite answers to this statement right here, but there's only one answer to this, because there's only one angle in this range that has the right value. So let's do this again for the next problem. We're going to rewrite it, sine of theta, negative square root of 3 over 2. So I'm looking for theta such that I get a sine of negative square root of 3 over 2. I need to look in the proper range, and I memorize the range as negative pi over 2 to pi over 2. Since this is negative, I know my answer has to be negative. So I'm thinking of where is it negative square root of 3 over 2? Well, that's when theta is negative, and in radians, negative pi over 3. It's negative 60 degrees. Look on your unit circle to confirm that. So theta is, the answer is negative pi over 3. Okay, it's not a positive angle that's really large. It's a negative angle because of this requirement on the range. Tangent has the same range, so I'm going to use the same range for tangent. I'm going to rewrite it as tangent of theta equals negative square root of 3. I'm going to look on my unit circle. Tangent's always harder because it's not on your unit circle. You've got to do some calculating. But you'll find that the angle is, number one, it's negative because it's a negative tangent, so a negative slope. And it's also, in fact, negative pi over 3. If you calculate the tangent at that point, you will see that it is negative square root of 3. So there is your solution to the final example. Now here's your first question for your checkpoints, your multiple choice question. Take a moment to solve this, and then continue watching the video. So now we have to find composite functions. The next level of problem we'll have to be able to do is to find the exact value of a composite function. So composite means we have like multiple trig functions going on. We have a tangent inverse inside of a cosine here. So we still want to find the exact value. So here's the 2 steps, the 3 steps that I recommend following when you're doing this. Okay, some of it you might eventually do in your head, but for now you should write it down. Step 1, define what you don't know with a variable. Okay, the value that I'm looking for is not necessarily what I don't know. What I'm talking about is this inside value here. So tangent inverse of negative 6 equals theta. I'm defining that value as theta because I don't know what the tangent inverse of negative 6 will give me. I use theta because, remember, tangent inverse is asking for what angle has a tangent of negative 6. What angle? Now, the number one reason I do this is because now I can kind of rewrite this in more understandable terms. I can rewrite this as an equivalent statement that says tangent of theta equals negative 6. That's what tangent inverse means. The tangent of some angle is negative 6. Now, because of this, I can draw a picture of theta. Okay, the picture of theta in the correct range. So I have to remember my ranges still of my inverse function. I have to remember tangent inverse is from pi over 2 to negative pi over 2. So I'm going to draw a picture of this angle in the proper quadrant. It will not be over here because that is outside of the range. So I'm going to draw a picture of negative 6, the angle that has a tangent of negative 6. Well, that angle has to be in the lower quadrant down here because that's where tangent is negative. And remember, negative 6 really can be rewritten as a fraction as negative 6 over 1. And that's important because tangent is defined as y over x. Now, sometimes this could have been 6 over negative 1. But I know that's not the case because this picture has a negative 6 for y and a positive 1 for x. So I have the correct picture now because the tangent is -6 and it's drawn in the proper range. Now I have a picture of theta. Remember, theta is this angle down here. So theta is some angle that's negative because we've got to be in the correct range. But the question is asking, remember the question, go back to the question and find the value is our next step. Remember, the question is asking for the cosine of this angle, theta. Remember how we defined, and I'll try to use some colors to help you understand this. These two are equal, right? Tangent inverse of -6 is theta, and that's what was inside the cosine. So I'm really looking for the cosine of theta. Looking at my picture, I can find the cosine of theta by simply finding the hypotenuse here, or the radius of this triangle. And I'll do that by quickly using Pythagorean theorem and doing -6 squared plus 1 squared equals h squared. Solving this, I get 37 equals h squared, so h is the square root of 7. So I get the square root of 7 for h, the square root of 7 for h, and I can now find the cosine of the tangent inverse of -6. And that is going to be, the cosine of this angle is 1 over square root of 37. So the answer is 1 over square root of 37. But I want to make it proper, so I'm going to time top and bottom by square root of 37. So I'm going to get square root of 37 over 37. This is the correct answer for this problem. Now what's cool is you can check this in your calculator. You can plug this into your calculator, get the decimal, and then you can plug this into your calculator, get the decimal, and make sure they're equivalent. If you got the same answers, then you did the right work. Let's try one more, and then we'll get to your last checkpoint question. So we're going to start by defining what we don't know with a variable. It looks like, again, we don't know the angle who has a cosine of 5/13. So this is saying the cosine of some angle is 5 over 13. Okay, so I let cosine inverse of 5/13 equal to theta. That's what I defined theta as. Now I'm going to draw a picture in the correct range. I have to remember cosine inverse will always be in the range from 0 to pi over 2. So I'm sorry, 0 to pi. So this is not the correct range down here. And then I look, and since cosine is positive 5/13, I'm going to be up in quadrant 1. And so theta is an angle that's positive and greater than 0 and less than pi over 2. Now I'm going to label my sides on my picture. Cosine is defined as x over the radius. I'm going to use that definition because of this fraction, and I'm going to put 5 and 13. Oops, that's not x. 5 and 13 on my triangle. So 5 is my x, 13 is my radius. Now remember, the question is asking, so I go back to think about how I'm going to find the value. The question is asking for the sine of that angle. Because remember, that red circle is theta. It's asking for theta. So what is the sine of theta? Well, in order to find that, I need y. So I'm going to do some Pythagorean theorem. 13 squared is 5 squared plus y squared. I'm going to solve this. I'm not going to bore you with that, but you'll get y equals 12. Now I can find the value of sine of theta by doing 12 over 13. That is the solution to this problem. Again, punching it into your calculator, punching in this fraction 12/13, and punching in the original statement that was in the problem up here will give you equivalent values. Now here's your final checkpoint. Find the exact value of the cosine of tangent inverse of 2 square root of 3 over 3. Do your best to define your variable, draw a picture, and try to find what you don't know. Okay? Key thing here is to always draw that picture carefully and label the sides carefully. And then after that, it's just working with your fractions. So good luck, bring in those questions, and thanks for watching.